Morning. Hello, everyone. Hello. How are you?
Great, how are you?
Oh, I can't hear you. Wait, maybe that's me.
Hmm.
I think
Start again.
no, it was me. It was me. I
Okay.
actually did the uh,
You need
manual
to
mute.
say, oh, okay.
I'm going to spotlight all our speakers as they come in. Switch off all the notifications.
Hello, hi Ananda.
Hi, how are you, Jyoti?
Doing good. How are you?
I'm good, thank you. Let me add you to the spotlight. There we go. I'm just busy switching off all my noisy notifications and getting ready. Closing all the unnecessary stuff. Morning, everyone. Good morning, Saranjeet. Nice to see you.
See you.
We had about, I'm just trying to see how many registrations. We've got 70 people registered. Let's see how many of them show up. We normally have about a 30% hit rate. So 20 people, yeah, that would be good. Um, so we have a shared resource document where people can take notes or ask questions. And we also want to ask our participants, if you have any valuable resources to share, you're welcome to drop it in there or in the chat. We will also afterwards copy all the relevant content from the chat to the document. Ah, thanks, Jyoti. And the agenda, exactly. So you can also see what to expect from today. Um, yeah, indeed. I just noticed on the registration link that I don't see. Oh, maybe I didn't look. No, forget what I was saying. Yes. I don't see Abhishek's
Oh,
name on the registration. So I don't know if you've got easy access to him.
no, I'll just be
I,
accessing my email.
I'll email. I just emailed that.
Maybe just email on the same thread where he
Yeah.
responded.
Yeah.
Okay.
Um, oh no, I didn't. Not on that one. Morning, everyone. We're just waiting for our last speaker to join us and just giving everyone a chance to come into the Zoom room. We know we sometimes have people uh, coming out of other meetings, just grabbing a quick coffee or taking a bio break. So we'll start just after the half past. I joined another meeting a while ago. It was a meeting hosted by oh, I can't remember who. But they were playing the nicest music in this awkward waiting time. And I've been thinking if I was better set up, better prepared, maybe we can do that too. Because it made such a difference to this, I don't know, like, And
Okay, then.
I also had a meeting with someone who was traveling in, oh, Abhishek, thank you, yay. There we go. I met with someone who was traveling somewhere in Ethiopia from one town to another on a bus while they were giving their talk. And they had music in the bus playing and it was just also such nice music. Kareem, lovely to see you. Hi, everybody. Nice to see all the new faces. Mireille, welcome. Yeah, thanks, Sarjeet. I did that. So traditionally, we don't allow AI note takers in these meetings. We want people to feel free to chat freely about their experiences. And what we do is after the meeting, we will be recording the meeting. We do some editing, make sure that only the relevant parts are shared, and then we'll share that with everyone. We also share the resource document, which Jyoti just placed in the chat. So you're welcome throughout the meeting. If you come across interesting resources, if you know about interesting resources as our participants, welcome to drop them into the chat or into the resource document, and we can share it with everyone afterwards. Also, all of the valuable resources that our speakers will be sharing will go into that resource document, and we will share that with everyone. And then we also write a short blog post just to summarize the conversation for people who need to be reminded of the highlights or people who are unable to attend and don't have time to watch the recording. So I think with that, we cover most of what the AI note takers would do, but in a more personal way. So for those of you who have missed out on previous events, you can refer to the website. There are the recordings, the blog posts, the previous resource sheets, and they are within each event page. So you're welcome to also refer to those if you are interested. And I think with that, we can probably start. Jyoti, what do you think? Yeah, we're ready?
Yes.
Good.
Yep, we can get started.
Excellent.
Hello. Hello and welcome everyone. I'm Jyoti and I'm very excited to see you all in the fifth episode of our ongoing series called as Enabling Open Science Through Research Code. Today we will be discussing one of the important pillars in writing good softwares, which is testing the research code. Today's session is inspired from a lesson from Code Refinery on software testing. So at times it happens that the code written does not give us expected results. Also, sometimes we make some change in one part of the code and unintentionally that changes some other part of the code and it stops giving expected results. So these are the scenarios that can be resolved by including code testing at different phases of code development and deployment. So in today's session, we will explore what code testing is, how it helps in writing robust softwares, what are the different types of codes. Also, we will see how to implement and integrate simple workflows into the research code development cycle. We have three speakers on board today, and I will be introducing them one by one. I'm pasting some questions in the chat. I request each of the speakers to answer them one by one. So we'll start with Abhishek first. And Abhishek, we'd like to hear from you about what did you study and where? Do you have postgrad qualifications in what discipline? What is the title of your current role? And give one sentence summary of what you do in this role. Over to you, Abhishek.
Thanks, Jyoti, and thanks, Saranjit, both of you, for inviting me to this panel. So I did my initial studies in physics in the Indian Institute of Science, Education and Research in Kolkata, India. And then I came to Oxford to do a DPhil in computer science. And now I'm a senior research software engineer in the Oxford Research Software Engineering Group. Well, I work with academics all across the university and beyond to develop their research software and also conduct training workshops to improve research software skills. So, yeah, that's what I do.
Thanks, Abhishek. Next up, we'll ask Ranjit about her intro.
Jyoti, thank you, Abhishek. Yes, so my name is Saranjit. Saranjeet Kaur. I am originally from India. I did my master's in statistics as well as MPhil in statistics from University of Pune in India. And I don't have a PhD. I have a MPhil in statistics. My current title is research software engineer, and I work at Imperial College London. I'm part of the Central Research Software Engineering team. So, as a part of that team, we collaborate with researchers all across the university from different departments, and we work on projects with the researchers. I'm also the co-founder of RSC Asia. So, yeah, that's where I am.
Thanks, Ranjit, for the lovely intro. Next up, we will go to Sheena to share with us about her.
Very cool. So I'm not an academic. I did study and did electrical engineering a long time ago at the University of the Witwatersrand in South Africa. We call it WITS because it's a mouthful. Um, so that was great, but always lent into the software development and software engineering aspects of that, and spent many years working in software startups of different types, a lot of like weird fintech things. Currently, I am working in software development education. So I founded an organization very recently called Prelude, where I do training. So I've been working in education for the last like 5-ish years in different ways, and that's been really, really cool. So I've been taking everything that I've learned from there and building a new organization that takes all of that to life in a greenfield way. And I founded an organization. Well, it's a community. It's a free community called the Guild of Educators, which is about helping software development educators by having the conversations that need to be had and spreading skills. Because a lot of people get into education through the side door when it comes to software development, and I think it's important to empower these folks.
Right, thanks for the lovely introductions. I'll pass the mic to Anelda for the polls we have in the next session.
Thanks, Jyoti, and thank you very much to our speakers. You would notice that we have a nice mix of backgrounds in amongst our speakers, and that's very purposefully done. We realize that research software development is a very underdeveloped field, and we really encourage strongly to connect also with professional software developers to gain from their experience, and also see which of the best practices we can implement in the research software space, because often we find that research software developers have limited formal education in software development. It's often self-learned, self-taught, learned through a community of practice, and it can be quite daunting to bring in those best practices if you don't have experience with that, or don't have a community around you that have implemented things like testing, like best practices around documentation, collaborative coding, and so on. So I'm Anelda van der Walt. I'm the co-lead for RSSE Africa, and I run Telarify, a South African company that teaches digital and computational skills. We work in open science, and we work across all research disciplines. So really, really lovely to see all of you here, and also see the diversity in terms of backgrounds, where people are from, and that's what we're going to ask you now. So we would love to hear from the audience. Where are you from? What are you currently doing? What is your interest in research software or testing? Do you code? What are your favorite languages if you're already coding? And if we can get a little bit of feedback from you in the chat, that would be great. Okay, so let's kick off this panel. Thank you very much for introducing yourself and giving us a little bit of a sense of who's in the room. I think it also always make it easier for our speakers to provide more contextual information that will be relevant to the participants. So we're going to kick off this panel discussion, and first of all ask, what is software testing? And Abhishek was brave enough to say he would tell us a little bit about his opinion on what software testing is. Abhishek, let us hear. Thank you.
Yeah. So, well, to me, software testing is just making sure that the critical bits of your software that are essential for your research work as intended. So this is not only to help people later on reproduce your code, but also you in 1.5 years when you have to dig out your old code and maybe make some changes because you have changed the study protocol, or you have added some fields to the analysis, and then you suddenly don't know if the code works. Like, it's obviously going to make an output, but it's not going to be correct, or maybe it is correct. You don't know until you test. So that's why I'd say, yeah, software testing is very important for research software.
Thank you. That's a very good and I think accessible definition there. We'd love to hear from you in the chat as well. If you have anything to contribute or any additional questions based on what is being said in the panel, you're welcome to, throughout the conversation, just add it to the chat. We are keeping an eye on the chat, and we will incorporate your comments and your questions throughout the conversation. Let's not wait until the end to ask questions. So building on what Abhishek has just shared with us, we'd like to ask Sanjit and Sheena, how can software testing improve research reproducibility and collaboration? And I don't know, maybe let's go with Saranjit and then Sheena, and then see how that where that conversation goes.
Yeah. So one of the examples that I would like to give is when I was doing my master's, even I didn't implement testing. So to be very honest, I wasn't aware that these are some of the good development practices. But then when I ended up learning more about software, I realized it's a very useful tool to have in your kit. So, for example, as a researcher, if you're working on your code on your machine, and then you share it with your supervisor or you share it with another researcher in your collab, and you suddenly find that the same code that was working on your machine, on your operating system, just doesn't work as well on their machine. So, software testing is like a way where you can ensure that your code works without errors across different operating systems. So, someone might be using a Mac, another person is using Windows, someone is using Linux. So, if you had tested your software before you shared it with anybody else, that would have ensured that your software is working across different OSs. So, this is one simple example that usually like I would have got stuck on, like, what is the problem with my code? It works on my machine, but it doesn't work on somebody else's machines. So again, there are also like when you're writing your code as a researcher, you might be importing a lot of libraries or packages. So you imported those packages on your machine, but then that's not available on another person's machine. So that's where your code starts breaking. So yeah, that's one example of why if you don't test your software, it might be a blocker in collaborating or reproducing the work on another machine.
Yeah, like untested code is just brittle. Like if you're building something that's significant, then it gets complicated over time. And if you don't have a way of validating that your code is running properly, then it becomes like making changes is a little scary because you're like, oh, what if it breaks? I won't know if it breaks. So if you test your code properly, if you write some automated tests, if you write some code to run your test for you, like there's lots of different types of testing. You can do automated testing, and you can do some like manual stuff where you run things and dig through the data yourself. There's a place for that. But the automated testing is great because you can validate that your stuff still works. So like let's say, for example, you've got a big project, you've been working on it for a year, and it's massive, and you want to use a new version of a package that you've been relying on, and you upgrade that package, maybe it'll break your code. It's possible. And so you just don't upgrade anything. Like you want to be able to check that, like, as you make those changes, your stuff still works. On top of that, you want to, like, as you build your code out, you're going to keep track of different versions of it over time, and your tests of those different versions will be helpful, because if you want to roll back and say, like, cool, this version of the code, I want to run that, you should be able to reproduce the way your code was working at different points in time as well. Because maybe you made a mistake. Like research software, and like all software development, really, it's very explorative. like you don't know, you don't always know where you're going. You sort of kind of know, and you tend towards your objective, and then the goalposts change, and that's normal. So you really need to have a way of just like iterating safely, and tests help you with that. Um, on the collaboration front, tests are like ridiculously helpful. We spoke about sharing code already, and that's great because somebody else can download your stuff, install your stuff, run the tests, and see that it works on their computer. But then there's more to it than that, because tests themselves, um, like if you are writing tests for your code, then you're writing testable code. So it determines some things about the structure of your code. It makes it more modular. It makes it a bit more like easy for other people to read and interpret and reuse. It makes it more maintainable. That's a big deal. And good tests are also good documentation. So like your code could be like quite complicated looking, and then your test will say like, in this specific situation, I expect it to look like that. In this specific situation, I expect it to look like that. And that makes it way, way clearer. Like a lot of the time it makes sense to, like if somebody gives you some code to read, like read the test first and see how it's meant to work. Um, so that, yeah, there's a lot of good things. It's also like if you know that your code has some acceptance criteria, it's like in the end we need it to do this thing, then you could code that up as a test early on, and then you'll be able to tell if you met your requirements or not automatically, and that's very helpful. You won't be guessing anymore. So yeah, many reasons why it's useful.
Thanks,
Thanks.
that's great. I just want to give one comment, Jyoti, before I hand it over to you. I was recently teaching to humanities researchers to learn to use Python, and they have very, very limited prior exposure to coding. But it was very, very interesting. We were doing something. And normally I think of people learning to use testing as a advanced skill. It's not the first thing that you learn when you learn to code. But we ran some code, very simple code, like a one-liner, like it shouldn't have worked, and it did work. And we were all like, why is this code working? And then we had to look back, and we saw that the data object that we used in this line of code was of a different type than we expected. But we didn't know that the type was incorrect because we didn't test like what is the data type that we've imported. And there and then both of them were asking, so how would you know if you get output, if the output is correct? And so we were talking about assertions in Python in the very, very early phase of their learning to code. And I was thinking about, well, this is actually what we should be doing, right? We can't leave learning about testing until you've developed bad habits. So that was just really, really interesting for me from a trainer's point of view. At what stage do you introduce testing? But I'm going to hand over to Jyoti now for the next discussion.
Yeah, thanks, Saranjeet, Anelda, and Sheena, for explaining the importance of software testing in very simple examples. So moving on, we have the next question for Abhishek, which is what are the most useful types of tests for research code? Some of the examples are unit test, integration test, regression test, and property-based test. So over to you, Abhishek.
Yeah, I mean it's hard to choose the favorite kind of test. Like use all of them, really. So in terms of the differences, the unit tests are, well, as the name says, it's unit tests. So you test like a small unit of code. So I think unit tests are nice to get started with testing because it's not much work to add for a small unit. It also encourages, as someone in the comments said, to break down your code into chunks so that you can test it. I do think that integration tests are very important for research software because ultimately what you're going to publish in your paper is a table, some plots from that table, and some data. So you need to ensure that your data pipeline runs end to end and runs consistently, runs reproducibly, runs across all computers. and that is an integration test. So that's not an unit test. So if you only had to write one sort of test, I'd choose integration tests. But yeah, please do write unit tests as well. They're fun to write. They're quick to run. They give you immediate feedback. They give you the green ticks, which are amazing. And property-based testing is, I think, more advanced. So that's when you don't know exactly what you want to test for, but you want to test it against a range of different values. You don't know what values will be passed, so you want the computer to come up with those values and test it. So yeah, if you're starting out, I would not go for property-based testing, but yeah, that's a good tool to have once you are familiar and competent with like integration and unit testing. It really pushes your testing up a notch, especially if you're working with a lot of numerical data that can come from various sources. It makes your code more robust because then you suddenly know, oh, my code only works but for positive numbers, which may be common sense. But then if someone puts a negative number in Excel sheet, they just type minus by mistake, and then suddenly get the best thing is it crashes, but then the user doesn't know why it crashed. The worst thing is it doesn't crash and it gives you a different output, when really what should have happened is you should have caught that value. So that's what property testing gives you, is that it goes through the various range of combinations that would be hard for a human to do, and or it just tests with numbers like infinity, which is actually a valid floating point number, right? In the computer, and normally you'd never be testing with infinities in your code. So those are the useful things. But yeah, to start with, integration tests, and then unit tests, and then property tests would be my order. But yeah, try them all.
Thanks for those suggestions, Abhishek. We have our next question for Saranjeet and Sheena. And the question is, what are some lightweight testing strategies that researchers with minimal programming experience can use? Who would like to go first?
I don't mind going second. Or first.
Yep.
Okay.
Yeah. So one of the, like, I think Sheena had also made this comment earlier. So in testing, you're writing a software, so you have some idea of what it's going to give as an output. So you can use that idea to write your very first test. So for example, if you're writing a function, like a very basic thing, you're writing a function to like add a few numbers, then you can give the expected output to it, and you can test whether it's equal, the output that your software is giving is equal to the output that you're expecting it to give. So you could use assertion statements over there. I think Anelda also mentioned earlier. So assert statements are quite easy to start with if you're starting on your testing journey. Um, I can also speak from if you're writing code in R, then there is a very nice package called as Fusen. It's it's in that package. What you would do is you would use that package to write all your in one markdown file, and then write separate chunks for your function and for your test, and then it will automatically test everything and build the entire package for you. So yeah, I'll drop a link to that package. I think it's quite handy, and I'm also writing a blog about it, so I can share it once the blog is um yeah. Link.
Cool. So I fully agree that starting off with assertions makes a lot of sense because it's so lightweight and you can just put it in the code, and it'll act as documentation, and that's great. Like, so I've taught a lot of people how to test software, and I found that like teaching people the tools is the easy part. Teaching people the mindsets around like what to test, that's way harder because it'll be like, what even needs a test? Does this function need a test? Does this block need a test? So if you start off with assertions, then you get some reps and you get some practice in. You learn to see where the brittle parts of your code are. You learn to like figure out how to zoom in on the broken bits, and that's very, very helpful. It's also like one of the challenges of adopting unit testing or like testing in general as a team is that if it's like I don't know how many people here have like tried to cut down on candy or smoking or something. Like you can know that something is good to do and then just not do it. And if you write a test suite and nobody's running it, that's not helpful. But if the assertions are buried in the code and to run the code, you have to run the stuff, then it sort of takes away one opportunity for human error, which is very helpful. Like if people can forget to do a thing, they will forget to do the thing. This is a little, um, so that's very helpful. And some of the mindsets you learn from doing that are really, really useful. Like I've seen so many beginner developers get frightened of errors. Errors are good. Like people see errors and they're like, oh no, make it go away, like squash it. We'll just like catch the exception and then print something out somewhere. And it's like, no, no. Errors have been implemented in Python, in R, in Java, in C++, in Clojure, in like every freaking language because they're helpful. And if squashing them and printing them out was the thing to do, then surely the clever people who made these languages would have done that. So it'll give you an appreciation for errors and how they can help you. So yeah, assertions as a first step are fantastic. And then another like really useful thing is that like I just call it smoke testing, which is like, does it run without errors? If you have your assertions in there, then you can, if you just like run through the code and make sure that it doesn't break in any obvious ways, then that's like a good step. Like a lot of people don't even do that. And if you can get it to run in a consistent way, then that's good. So there's this thing called, I think it's NBVal. So it's something that you use for testing, for running notebooks, and so Jupyter notebooks. And basically it'll run every block in order and it'll say like, okay, cool, we know what the output was the last time. Is the output the same thing this time? And if it's not, it's a problem. So it'll run all your assertions and it'll make sure that your code runs in a sensible order. Because sometimes the experimental nature of building these things means you'll write this, then you'll write this, and then this one needs to run before this one, and it gets it to be a scrambled mess. And like people are like, I'll just remember to run it in that order, and that's not great. So having something that will automatically run your code in like a consistent way is very, very helpful. Then I'd say unit tests. So there are testing frameworks that are lightweight and heavyweight. I like Python. I use Python all the time. PyTest is wonderful because it doesn't have a lot of like weird boilerplate. You can just like write little functions and it takes minimal setup. So once you get into that, then it's good. I'd also say like if you can get like if you're working on a team of people and you're trying to figure out how to introduce testing as a team, automations are going to help you because it'll like enforce that good practice without somebody walking around being like, hey, did you test your code? So yeah, lean on that. Yeah, I think that's most of it. Yeah, assertions are great. Is the first step. Yeah, and just another thing on assertions, you can do interesting things like say, like you can put in really lightweight assertions at different points in your code. So you can say, cool, I've got a data frame. I assert that it has this many columns and this many rows. I assert that this column is positive and this one's negative, and so you can really just like dig into the shape of your data, and often that's enough that you can catch many bugs. Yeah.
Thanks, Sheena and Sanjeev, for the very detailed comments. Anelda or Abhishek, would you like to add something on this?
No, I like that. I've been Googling as you were talking and just dropping some links into the chat as well. I'm sure there's some other people who have useful resources to share as well. Abhishek, did you want to add anything else?
No, I just found out about NBVal, so this has already been helpful to me.
Thanks, everyone, for sharing all these resources. I think the audience will find it really helpful. Now, moving on to our next question for Abhishek and Sheena. So the next question is, if someone has ever written a test before, if someone has never written a test before, what is the simplest way to get started?
Oh, again, I know Python, so yeah, install PyTest and write a test function, which could just be like 3 lines, like assert 2 + 3 = 5. make sure it runs, and then start testing your code. I definitely not start with the unit test for Python. It's just like really, really clunky compared to PyTest. So for Python, do PyTest. For R, there must be other tools like TestStat, for example, which are really good for testing. So yeah, start with very, very one-liner tests. Of course, start with asserts, but yeah, as someone said, like asserts are not technically tests in the same way. So start with that, but then move on to one-liner or few line testing, unit testing, using a lightweight framework, and then move on to integration tests. The Python itself comes with unit tests. So thankfully, most of the online documentations, if you Google how to test in Python, or maybe if you ask ChatGPT, you'll probably get like PyTest now. But at least a few years ago, you used to get a lot of, if you Google how to test in Python, you'd get a lot of unit tests, because unit test is what Python ships. It's bundled with Python, so you don't need to install anything else, which is nice, but it is very clunky. So it's really worth installing PyTest to test your code. Yeah.
Yeah, I agree. PyTest is way better. It's just like, especially if you're new to testing, you don't want to be hitting your head on on like learning this framework for testing when you can just like write little functions. Yeah, I think so. If you're getting into testing for the first time, like chances are, if you're here and interested in this, you've been writing code already and you're already working on something, and you're like, how do I get some tests into this thing? So I think the first thing is like, if you're writing new code, try to test your new code as you go. So sometimes it's a bit hard to go back and test things when they're already there. Like it's a bit hard to think about, and the code isn't necessarily always structured in a way that'll make it easy to test. So check some assertions, but then with your new stuff, like try to write it in a testable way. So like put your code into functions and call the functions, instead of just like having scripts, instead of just having like a bunch of statements. Be like, okay, cool, this is a function and I'll call it, but then my test can also call it. So you'll start to learn to structure your code nicely. And then another really nice way to introduce tests into existing code is like chances are at some point you'll notice something that's broken. It's really nice to fix bugs in code in a way that's like test driven. So if you see something that's broken, write some tests that prove that it's broken, if you can, and then fix it, so that your tests pass. So sometimes this will require a little bit of refactoring along the way, and assertions again will be like a nice safety net to help you to do that without breaking anything else. But eventually you'll get to a point where you are able to write testable code, and that's just like tidier, better code. I think also if you do find yourself needing to refactor things in order to write tests for all the code, like it can be a nightmare sometimes, depending on the complexity of the code and the weirdness of the errors. But like having some kind of integration test is helpful to say, like, at this point in time, I expect it to behave like this. Yeah, it's helpful, but it is an adventure.
I really like the tip shared by Sheena about how we can write tests in the form of functions and run those functions as and when required. Yes, go ahead, Anelda.
No, I was just thinking as you were talking, we're always thinking about how can we get newer people who are new to coding into proper projects. And it sounds almost like getting your interns or whatever to write the tests for your existing code might be a very interesting project, because you don't want to go back and rewrite the code that you think already works. And writing the test isn't necessarily so burdensome or advanced. It doesn't have to be a very advanced coding, but they will have to look at the code that exists, see if it does what you expect it to do, write the code. So that's actually a very interesting possibility of bringing newer coders into your projects.
That's possible. I think it can be done well. I also think it can be done badly, because I've seen people hire junior developers and just be like, I don't want to test the code, you test the code. But actually testing your own code is a really good thing for you, because then you learn the skills of like getting your getting your code to be testable and structuring your code properly, and like there's mental discipline involved in this thing. But if you write some code and then you just say like, hey, you test it, then it can be like maybe they don't even know what the code's meant to do, and then they write tests that don't test the right thing. So yeah, it's tricky, and it's also hard. Like if you've got an existing code base and it's big, then it's like there are certain critical points in that code base. There's some easy stuff, and then there's a weird thing, and then there's some more easy stuff. And expecting somebody who's new to the code base to identify the weird thing that needs all the tests, like it might not happen. They might like start from the top. Yeah, so it's just move with caution. I think it's like potentially useful to pair program with people or get them to throw in some assertions and be like, okay, cool. How do you think this code is working? Like at these points, what are you expecting about the data? See if people are able to be intentional about their code, because sometimes like beginner programmers aren't that intentional about what the code is doing. They're like, there's a lot of pattern matching that happens where they're like, oh, like in this situation, there's a data structure with 2 dimensions. Therefore, I need two for loops, and they're not always like as clear on like yeah, like a lot of things. So verifying that they understand the code by putting their understanding into the code could be really cool. Yeah, but it is tricky in many ways.
Excellent, thanks. Managing expectations there. So we're going to move to something more technical, maybe for the more advanced programmers in the audience. We're going to look at how can version control, for example, Git, and continuous integration help automate testing in research projects, and of course in other software projects as well. Abhishek, do you want to get this conversation started there?
Yeah, I mean, it's very helpful, like really helpful. So, okay, the reason version control is useful is just even for getting testing is just useful because you want to go back and see how you have changed things, when you have changed things, to get back a old version of the code. To if you're collaborating, it's an essential tool because you would need to review your collaborators' code and make sure that it works, and also passes the tests, for example. So then you have, so I think version control is necessary for continuous integration. Once you have version control set up in GitHub, for example, then you can set up continuous integration, which means every time you push to this remote repository, your tests get run automatically. That's good because you don't need to remember to run the tests. The computer is going to do that for you. In most cases, for most reasonable projects, and especially if your project is under open license, it's completely free to do that, so that you don't need to pay anything. The benefit is that, especially if you're developing on a non-Linux system, for example, it automatically checks that it runs on Linux, it runs on Windows, it runs on Mac, which would be expensive. Like imagine trying to have 3 computers or trying to dual boot Windows and Linux and having a Mac computer just to run your code. Like, yeah, if you have, go ahead and do that. But here you don't need to do that. It's just for free, and you get testing across all 3 platforms without having to, get go over to your colleague and say, hey, do you have some 5 minutes? I want to run the test on your machine because it's a Mac and I don't have a Mac. So super, super useful having this continuous integration set up. And GitHub is particularly good. Like if you create a new Python project, so if you go to the tab called Actions, so that's what GitHub calls its continuous integration system, it should give you templates, or I think in the sidebar. They keep on changing the UI, but it's somewhere in the sidebar you'll see pop-up suggestions saying like set up testing with Python, right? And if you click on that button, you just go through a very, very user-friendly process where you can set up continuous integration. I think it recommends PyTest for Python. But it has templates for all kinds of code like R, C++, Rust, Python, all languages. It will have these templates and as long as your project repository follows a standard format that people use with Python, for example, you have a setup.py or a pyproject.toml, then it's like one click to get this set up. And once it's set up, it will run on every pull request, it will run on every branch that you push to GitHub, and it will keep checking. And that's when you get the green ticks, by the way. So you don't get the green ticks if you don't set up continuous integration. So that's where I really suggest setting that up as quickly as you can for your own code.
Awesome. Yeah, so Git is fantastic. It's so necessary. I think that like when people are new to Git, they don't always respect it. They don't really know what it's for because it's weird. It's like super strange in the beginning, which is normal. So it does version control. And when people don't know Git, then they do version control by copy pasting their code and giving it weird names like version 1, version 1 final, version 1 final fixed bug, version 1 final really. And it's weird. Like it gets very tangled, and each of those versions is probably a whole bunch of files, because like especially if you're working in research, chances are you've got some data involved in those as well. Chances are you've got like I don't know, like maybe there's a couple of notebooks, maybe there's a couple of different things going on, right? So you've got these like big chunky things that you copy and paste around, and now you need to remember which one you're working on. And if you open the wrong one, then you're in a mess. And if you've got a bunch of people working on the code project at the same time, then everybody's dealing with that mess. So like, let's say you've got 4 versions, and now somebody's implementing a feature and somebody else is implementing a feature, and they each like look at the last version, they make their own copy, they implement what they need to do, and now you need to merge that code together, and it needs to be accurate and precise line by line. And you need tools to do this if you're collaborating on anything, like anything serious, because you will shoot yourself in the foot, and you will shoot your peers in the foot as well. Like there's nothing worse than somebody just like doing their best job possible and like just breaking all your stuff. It's like it's not only inefficient, it's just like it's a bad vibe. It's bad for the collaboration in general. So Git helps you with that. And then it lets you back stuff up as well, which is really nice. You can back stuff up to GitHub for free. There are other platforms that allow you to do that. Like if something happens to your computer, it should be like your code and your hard work should not be gone. So yeah, very important tool. I generally find that the people who need to learn it the most like don't know that they need to learn it. But it is an industry standard for a very good reason. So learn Git. And then on like the other thing that's really cool about Git, and it's like how powerful it is as a version control mechanism, is you get to do experiments with code. So again, like software development tends to be a bit of an adventure, tends to be exploratory. It's a creative process, and sometimes you'll be like, okay, I want to build this thing. I don't know if it'll work, and you want to try it, but you'll need to try it in a way that's kind of isolated from your collaborators, so you're not like standing on their toes and messing with their stuff and adding confusion. So that you have these like isolated versions of the code that you can merge together if you want to, but you don't have to. That's super helpful. It lets you roll back to any version that you've had so far. So if you have gone down the wrong path, then you can roll back and be like, okay, cool, this version was working. Or this version was working in that situation, for whatever you need. Yeah, then continuous integration, again, like because Git is like such a well-used tool, people have built tools on top of it, built tools that like allow you to get it to dance in new ways. So continuous integration is part of that. So as you make a new version and push it, which means like upload it to GitHub, then you can set GitHub up so it can run your test for you. So remember earlier I was talking about how like expecting people to remember to run the tests. It's probably I'll probably forget sometimes. And get the machine to do the remembering for you. It's super helpful. I think that's everything. Yeah, I think that's about it.
Sarji, did you want to add anything there?
Yeah, I think I completely agree with what Abhishek and Sheena were saying about using Git to version control your work. It really helps when I think Sheena mentioned this already, but when you're comparing different versions or different copies of your own work, you don't have to go like check each line whether you have reproduced it correctly, and Git will do that for you. So I guess that's really helpful. not just for testing, but in general for writing software. It's a very useful tool to use. In terms of continuous integration, I use GitHub a lot, and in GitHub, when you set up your actions, you can set up like workflow or GitHub action files. So if you have ever like explored GitHub repositories that have like a .github folder, um, if you go inside that folder, and you would usually find another folder called as workflows, and that is where you would put all the automated tests or actions that you want GitHub to run for you. In R, it's very useful to have to get an idea of if you haven't used this package before, but it's a very useful package. It's called Use This, and that helps. Like it takes a lot of headache from you, even if you're developing a simple project or if you're developing a package, irrespective, it's very useful to use this package in when working with R. And there is a function in this package which is for especially for setting up your GitHub actions or workflows, and that would help you set up standard actions like RCMD checks, or it can also like publish documents for you each time. Like again, I think Diego mentioned in the code, you should not be running actions so frequently because it does consume a lot of energy or computational resource. But there are ways possible where you can like automatically publish things or automatically run some checks. So if you are our user, I would highly recommend referring to those packages.
Thank you so much for those valuable resources that people are sharing, and for the advice. My head is spinning with ideas about where do we go from here. This conversation just seems like, okay, it's nice, we've spoken about it, but now what? How do we help people to actually try these things that you're talking about? So I hope that by the end of today's session, we can share a few upcoming workshops. I know you also do training. Don't know if you specifically incorporate testing in your training, but also at the different universities that people are working at, there's often training. I know the Software Sustainability Institute also run their code camps. So there are a wide range of training opportunities that comes around throughout the year, and we'll make sure that we share those here, and of course also on our different social media platforms and so on. What tools and frameworks would you recommend for testing in common research languages like Python, R, MATLAB, and so on? So I don't know. Sheena, you're unmuted. You want to
go? So there's two or three more that I'd like to mention. So there's one called Pandera, which it's actually pretty new to me, but it lets you do things like define the schema of your data and then assert that it is as it should be at different points in your code. So it looks like it does a whole lot more than that as well, but you can say assert that the data frame has meets these requirements, which is really cool. And then, so I'm only going to talk about Python things because that's my jam. Then there's another one called scipy.stats, where you can assert that things are statistically similar to what you expect. So even if the data is a bit weird and random, you can say I expect the p-value to be kind of like this, and that can be helpful as well because you do deal with some random things sometimes. Yeah, I think those are and then there's hypothesis as well, which is it was mentioned briefly earlier, but maybe worth just mentioning again now. You sort of so if you have a function and takes in some numbers, then you want to be able to test that it works in a predictable way across a range of numbers, and so you can find all the edge cases and all the weirdness that happens. So it'll so you won't need to parameterize your test and run it again and again and again yourself. You'll just say hey, hypothesis, throw some numbers over there, and it'll sort you out. So those are very helpful. Can also mention something about training. So I don't currently run any training on testing. It is something that people keep requesting though, so I think I should do it. I do have some Git training though that's quite thorough. this is something I run on request though. So if you have a group of people and this is something that you'll find interesting, then get in touch and I would like to help.
Yep. So if you're using R, I think get more familiar with the use this test suite because it has a lot of these packages incorporated. There is one particular package called test that. Again, if you're using it with use this, you could use it with a simple command use test, and it will integrate test that into your development workflow. But if not, then you can also use it independently. The other package that I had mentioned earlier was Fusion that also has test that inbuilt. So if you're using Fusion to develop your software, uh, it should automatically call the test that library and should build the test files for you, but you have to populate those files. It will take care of the infrastructure setup for you.
Okay, that's wonderful. Abhishek?
Yeah, I mean, I mostly work with Python, so just use PyTest. And there's a ton of documentation on PyTest. I think, in fact, Diego linked one as well. So PyTest is very good for starting off, but also it has a lot of features to help you write tests better, like fixtures and parameterization over various. So if you want to run a test over multiple, inputs, then you don't need to copy paste the function. So yeah, a ton of stuff in PyTest. Then things like setup and teardown. If you need to say set up a database before actually running tests on it, and then delete the database, then there's modules to do that for you. So yeah, just have a look at the PyTest manual. It's amazing. Yes, Tox as well. Yeah, I've not used much of this, but yeah, this is useful for running across various Python versions, for example. And there's actually a new version called Nox. Yeah, everything's changing. So with Tox, I think you write in a sort of toml ini kind of format to specify which versions of Python you want, and with Nox you write the Nox file in Python. So yeah, if you want to test on multiple Python versions on your computer, then using Tox or Nox is one way of doing it. Um,
So there's obviously a range of people in the room. Some people are developing code to maybe analyze their own work, and they might not care so much about whether this code runs across different Python versions or R versions and whether it runs on Linux, Mac, and Windows. So if you are that person, we hope that this conversation is not intimidating you too much. Remember, you will only apply the tests that are relevant for the work that you are doing now. And when your code is adopted by a larger community, then you can worry about the rest. But you don't have to think from the start that I'm writing this code and now suddenly I have to know about all these packages and all these functions and platforms and testing protocols. I think if you are the person writing the code for your own data analysis, there are some minimal tests that you can implement already that can make your code less brittle, as Sheena was saying. But if you are on the other side of the spectrum where you are working in collaborative groups, where you're developing larger tools that are being used by a broader user base, then of course there's probably more that you need to do to make sure that the code is usable by everyone. So Jyoti, now I can hand over to you for the big question.
The conversation has been going really well. And now I have the question for Abhishek and Saranjeet, which is how can researchers balance the trade-off between writing tests and meeting research deadlines?
yeah, that's a very, very difficult question. Yeah, I mean, it really depends. Like, obviously, if you're a research software engineer with that hat on, I'd have to say, well, sorry, you have to test. Like, there's no way out of it. If you are a researcher, though, the reality is that there is a lot of incentives not to do like a very thorough job of, like, having a very nice package, because that's not what you're being paid for, really, in some sense. There is very little incentive within academia to really have software for very high quality for various reasons. There's pressure to publish. There's also a reasonable case to be made that not every piece of code needs to be of quality of like pandas or scikit-learn or something, because it just takes a lot of time to do proper testing. Like, even if you set up tests, getting your code coverage to 100% is a lot of work. So if you have time, please test. If you do not have time, do integration tests. Just run again. You don't need to necessarily set up CI and all that. Have a script that or instructions in your README saying, here is how to get the code. Here is how you have some sample data, and here is how you can check that the code runs, right? And maybe it'll do some assert statements, maybe it'll run PyTest, some unit testing framework, and it'll give you green on your computer. So that, I think that should be the bare minimum, is that someone 5 years in the future, maybe you or someone else, gets your data from the data repository, like Dataverse, for example, gets the replication code, and they can replicate, right? Because again, if you can't replicate the code, then at all, and there is no test, then there is no way to run. So I think there's no way to check that it actually works, and maybe it doesn't work, right? So, there's the famous Ranat and Rogoff case where they missed a few cells in Excel and came up with an entirely different policy for economics, where they suggested, I don't know, I think it had something to do with austerity. I remember that about GDP and how it goes with increasing austerity. But essentially that error was found by a student like 5 years later, or a while later, and because he tried to reproduce the work and found that it didn't work. Now, would it have taken 5 or 6 or 3 or however many years it took if they had tests? Probably not, because they would have found themselves that it didn't work. So integration tests are very important to have for ensuring that scientific workers are reproducible. The smaller unit tests, performance tests, possibly not so much. Setting up a nice CI, good to have, but if you have scripts to get your code, run the tests, then I think that's enough, really, for publishing your paper.
So I think I sometimes researchers, like most of the times, they would feel that if their code is working, if it's not throwing any error, it's perfect, and it won't result into any further errors. So they would stop there and they would not bother to like test their code even further or think of corner cases. So I think Abhishek was saying that you could avoid GitHub Actions, but then I think you could take benefit of using automated testing and have GitHub Actions set up if you don't want to, if you don't have the time to test all your work. The other thing about, we were also talking about meeting research deadlines. So one thing that often happens is when you're running your code, and if it's computationally intensive and it consumes a lot of your time, um, and if you're running your code again and again, that also adds to the time that it takes. So in R, it's possible that you could use a framework, which is it's called targets. So what it will do is it will only run whatever new code you have written. If a computation was done previously and you haven't changed anything there, then it would skip that step and then only run whatever new computation has been introduced. So I think it's yes. Thanks, Abhishek. I think it's a good package to use, and it's I think it's popularized as being how to make your code more reproducible. So I think it will also help with saving a lot of time when you're developing your work in R.
Can I add something to that? Sweet. Sorry about the interruption earlier. I thought you're done. Yeah, so I think that like people think that there's a trade-off between building the functionality and writing the tests, and they're like two different workloads. But writing tests early actually adds quite a lot of leverage. So it feels like extra work. But like if your tests are solid, then you have confidence in your code. And so you don't waste time second guessing your code, and you don't waste time having to deal with weird bugs that you could have avoided in the first place. So that's like it saves time. And on top of that, it's like if you're writing testable code, then your code is structured better. And that saves you time later on if you want to reuse your code in any way, if you want to maintain it. So that's like if you want to extend it to do more stuff, or if you without breaking its existing functionality, or if you want to just like take a block of code and use it in a different project, you'll know it works. So that saves time like every time you reuse the code. And it also, again, it adds that clarity to your code because it acts as documentation a lot of the time, especially if you're doing like inline assertion and stuff. Um, that clarity, again, saves time because projects take a long time. Sometimes you'll write some code and you'll go away and you'll do something else and you'll come back and you'll be like, what kind of maniac was I when I wrote this code? That's a normal experience. But if you've like made the code really clear and made the tests clear, then it takes the edge off that. Like one way to think about code is like there is an end goal, right? And you should think about the client and what they need and whatnot. But you should like one of the clients you should always consider is the next developer who's going to be in the code. And maybe that's you, maybe that's someone else. But try and serve that person and your code will always just be better. So it'll feel like it will take extra effort upfront, but it pays dividends.
I
Like
absolutely
if you
love it because it's I think, so this is the 5th episode that we're running in the series. And the one thing that have repeatedly come up is the things that we've been discussing that makes your code more open science aligned is the thing that makes you a better collaborator for yourself. So in following some of these best practices, you are the first person that's going to benefit before anyone else, really. So that's really, be your own best collaborators, the mantra of the series that's come out so far.
I think another useful way to think about when to add tests and things, like maybe you can code faster for a little while without adding them in, if everything goes smoothly. But there's this concept called technical debt, that's like if you've been around for a while, you're very aware of what technical debt feels like, and it is a debt. When you take out a debt, you pay interest. The interest you pay on technical debt is time and frustration. That's what you're going to be paying. So you have to like sometimes you want to take out the debt. Sometimes you're just in a hurry and it's just like, okay, I'm going to cut some corners here because I need to get this done right now. But it's good to be very intentional about it. So I think like skipping over the tests because you don't feel like you have time when you're not yet like super familiar with what tests give you, that's a bit sketchy. I think it's very important to like learn about the corners that you're cutting by leaving those tests out. Yeah.
Thank you. That was, there's some really useful information that's coming out of these conversations, and sounds like something that funders who are funding research software can also consider in terms of what are they funding? What kind of code are they funding? Is it documented? Is it tested? Is it on GitHub or like another platform? So very, very valuable, and also tying all these conversations nicely together. Is there anything else any of our panelists would like to contribute? A final word of encouragement or...
Writing tests is more fun than it seems at first. Yeah. Yeah.
Yeah?
Yeah.
Excellent. All right. Well, thank you very, very much to our panelists. Jyoti for co-facilitating and putting this all together. for everyone who shared links in the chat or contributed their experiences.